Hello everyone. In the previous session, I was doing the problems on binomial distribution. So anyhow, I have solved 3 problems. So in this session, let me continue the problems on the same, that is on binomial distribution. So here you have a next problem, fourth problem. So I have solved 3 problems in previous session. So continue the same and try to take running notes. So here is a problem. Find the probability that in 5 takes of a pair of a die, 3 will appear twice, at most 1, at least 4 times. So in the previous problem we have solved with reference to a tossing of a coin. But in this problem we are solving with reference to a throwing of a die. Right? So as you already know, when a die is thrown, what is the possible outcomes? Outcomes will be either 1 or 2 or 3 or 4 or 5. So I'll just write here, when a die is tossed, you will get sample space as either 1 or 2 or 3 or 4 or 5 or 6. Right? Now here what is the event that we should find the probability that 3 will appear. 3 will appear in the sense, here event 3 is successful event, whereas rest of the events, that is 1, 2, 4, 5, 6 are events which is failure. Right? So probability of a success event will be taken as P, that is probability of getting 3. Probability of getting 3. So what is the probability of getting a number 3? Is only once out of 6. It is 1 by 6. Similarly, we have to define an event Q. Q is none other than probability of not getting 3. It is a failure event, right? Not getting 3. Not getting 3 in the sense it is either 1 or 2 or 4 or 5, 6. So how many numbers is there? 1, 2, 3, 4, 5. So 5 numbers out of 6 numbers. So it is 5 by 6. I'll just tell you once again. See here. When a die is tossed, either we will get 1 or 2 or 3 or 4 or 5 or 6. See, P is always a success event. Here event given is 3 will appear. So this will be the success event. Rest of the numbers will be the failure event. So here probability of getting 3 is none other than only 1 times out of these 6 numbers. So failure event, this will be the success event, right? This will be the failure event. Now failure event is none other than not getting 3. So not getting 3 is none other than, except these 3, how many numbers are there? 5 numbers out of these 6 numbers. So that has to be taken as Q. Now how many times the die is tossed here? 5 takes, right? So small n value will be 5. So this is the first data extraction. Next we have to solve first question. First is twice, that is getting a 3 twice, right? So I'll just write the statement. Probability of getting a number 3 twice, that is the meaning, right? So we have to find probability of getting number 3 twice, that is we have to get a number 3 2 times. Fine. So what is the value of x here? See here, you should not take 3. Why? Because 3 is an event. We should get it twice. Twice in the sense we have to get x value as 2. Suppose if we have probability of getting a number 3 4 times, in the sense x value will be 4. 5 times, in the sense x value will be 5. Since here in this particular problem we are going to discuss probability of getting a number twice. So we have to get it 2 times, right? So it is given as twice. I'll just write for your reference. So x value will be 2. First let me write down the formula. What is the formula? We have NCX p power of x q power of n minus x. This is the binomial distribution we have. So let me substitute the values. N is given by 5, c x is 2, p is 1 by 6, whole power of x is 2, q is 5 by 6, whole power of n is 4 minus, n is 5 minus x is 2. Now let me simplify. 5c2, use calculator. 5 shift divided by 2. 5c2 will be 10 into 1 power of 2 is 1. 6 square is 6 is 36. Now 5 minus 2 is 3. 5 cube we need. So 5 cube is 125 divided by 6 cube we need. 6 power 3 is 216. Therefore probability of getting a number, probability of getting 3 twice, that is 2 times, is given by 10 into 125 is 1250 divided by 36 into 216. It is 77776. Clear? If you want, you can cancel. So after simplification, you just divide it with say 15. I'll just divide it with 15. Fine? Or else it is not divisible by 15. Let me divide it with 2. So 2 6 2 5 are 7776 divided by 2. It is 3888. Therefore, probability of getting 3 twice is 625 divided by 3888. So this will be the required solution for the first sub question. Clear? Next is at most once. Here it is given at most once. Meaning is probability of getting number 3 at most once. So as I already told you, at most in the sense you have to move to left of the number. 1 to the left you have 0. So you have to write it as probability of 0 times, getting 0 times plus probability of 1 time. Right? At most 1 in the sense you have to take 0 times and 1 time. At most in the sense you have to take less numbers also. At least in the sense you have to take greater numbers. Fine. 0 in the sense here the x value will be 0. Here x value will be 1. Now replace in the formula. Formula it is enough to write only 1 time. So n is 5. C x is 0. P is 1 by 6. Power of x is 0. Q is 5 by 6. Power n is 5. Minus x is 0. This is for first term. Plus for the second term, n is 5. C x is 1. 1 by 6 power of x. X is none other than 1 into 5 by 6 power of n is 5 minus 1. So this is what I have. Now let me simplify. 5c 0. 5c 0 is 1 into 1 by 6 power of 0 is 1. Into 5 minus 0 is 5. So we need 5 power of 5. 5 power of 5 is 3125 divided by 6 power of 5. 7776 plus what is the value of 5c1? 5c1 is 5 into 1 by 6 into 5 minus 1 is 4. So 5 power of 4 is 625 divided by 6 power of 4 is 1296. Now let me simplify. So you will get 3125 divided by 7776 plus 5 into 625 is 3125 divided by 6 into 1296 7776. So let me add these two values. 3125 plus 3125. You will get 6250 divided by LCM is 7776. So I'll just continue here. Fine. Therefore, probability of getting 3 at most once will be equal to 6250 divided by 7776. Either you can keep like this, or if you want you can divide it with 2, so that you will get 3125 divided by 3888. So this is the required solution of the second sub question, that is getting number 3 at most once. Clear? Now look at the third sub question. It is at least 4 times. That is probability of getting a number 3 at least 4 times. And in the sense you have to take one more number, larger number. 5 takes total number of tossing is 5 times we are tossing a die. So we have to take 4 plus 5. So I'll just solve here. Third one is at least, or probability of getting 3 at least 4 times. At least 4 times is given. So it is none other than probability of getting 4 times plus probability of getting 5 times. So when x 4 times x is equal to 4, 5 times in the sense x is equal to 5. So rest of the thing is same. You have to substitute in the formula. It is given by n is 5, c x is 4, p is 1 by 6, whole power of x is 4 into q is 5 by 6, n is 5 minus 4, x is 4. Clear? Similarly for this term, n is 5, c x is 5, p is same 1 by 6 whole power of x is 5 into q is 5 by 6. I am just substituting in a formula. Again n value is 5 minus x value is 5. Clear? Now let me simplify. What you have, 5 c 4 is 5 into 1 divided by 6 power of 4, 1296 into 5 minus 4 is 1, 5 power of 1 is 5, 6 power of 1 is 6 only. So plus 5c5 value, 5c5 1 into 1 power of 5 is 1, again 6 power of 5, 7776, 5 minus 5 is 0, anything power of 0 is 1. So this is what you have. Now let me multiply. 5 5 is a 25 divided by 1296 into 6, 7776 plus 1 divided by 7776. When you take LCM, you will get 7776 divided by 26 divided by 7776. If you want, you can cancel. 2 1s are 2 3s are and 2 3 8 8. Therefore probability of, if you want I'll just write the conclusion. Therefore probability of getting 3, at least, you have to write full statement, at least 4 times will be equal to 13 divided by 388. This is the solution for the third one, 13 divided by 388. Clear? I'll just show you once again. See here, this is for probability of getting a 3 number twice. So we have taken x is equal to 2. Here probability of getting a number 3 at least once in the sense at least you have. So you have to, at most you have. When you have most, you have to take less numbers. That is the number behind this. So it is 1 0 times, at most once 1 in the sense you have to take 1 here. So previous number is 0 times and 1 time. Clear? Similarly, probability of getting 3 at least 4 times, at least in the sense after 4 you have to take. So up to which you have to take in the sense, since here you may get confusion that here probability of getting a number 3 at least 4. Why should not we take probability of 6 times? Why? Because we cannot take 6 as it is given that in the problem since we are tossing a die only 5 times. So we cannot go behind 5. So it is up to 5 only. Suppose if it is thrown 6 times, we have to take again probability of 6 times here. Fine. Hope so it is clear. Please take a screenshot of this and copy it to the notes. Try to solve the problems along with me so that you can get an idea to solve. Fine. Now let me solve one more problem. So here is the next question. It is important. It is continuously asked in the year 2018, 19, 17 as well as 15. Find the probability that in a family of 4 children, there will be at least one boy, and at least one girl. Assume probability of male birth. Assume the probability of male birth is 1 by 2. Here the family consisting of 4 children, we have to find that what is the possibility of getting at least one boy and getting at least one boy along with one girl. So assuming that male birth will be equal to 1 by 2. Male birth in the sense, we have to find, whenever you are considering with reference to boy, you have to take the birth rate is 1 by 2. So here probability of boy, in the sense this will be the, reference event, in the sense successful event. So I'll just solve here. Solution, let P be probability of boy. So it is given in the problem itself, it is 1 by 2 as the birth rate is 1 by 2. So to calculate Q is none other than getting a failure event. In the sense it is the probability of a boy. We have already taken success as boy. So failure will be here probability of girl. Right? So failure event, remember, we can calculate by using the formula Q is equal to 1 minus P. As I already given this formula in what we have list. See here, Q is equal to 1 minus P. Why? Because p plus q is equal to 1. So q is equal to 1 minus p. By using this formula, we can calculate q. So q is equal to 1 minus p is 1 by 2. So q value will be equal to 1 by 2, whereas p value is also equal to 1 by 2. Clear? Now, how many children are there in the family? There are totally 4 children, right? So in the family, we have 4 children. So we have to take n value as 4. Now coming to the first sub question, it is probability of at least one boy, right? Probability of getting at least one boy. At least, whenever the term at least is there, you have to take more values. That is probability of one boy plus probability of 2 boys plus probability of 3 boys plus probability of 4 boys. We cannot go behind this. Why? Because as the family contains 4 children, whether it is boy or girl, we have only 4 children, so we have to take up to 4 only. Now 1 boy in the sense x value will be 1, 2 in the sense x value will be 2, here x value will be 3. Similarly, x will be equal to 4. Now write down the formula what we have from the binomial distribution. Same formula you have to write at least once. Try to mention the formula. Clear? So formula is given by NCX into P power of x into Q power of n minus x. Right? So I'll just do it directly. For first boy I am doing, so x is equal to 1, n will be 4, 4c1, p is 1 by 2, x for first boy is, 1 boy is 1, q is again 1 by 2, n is 4 minus 1. For the next one it is 4, n is formula, look at the formula, n is 4, c, x is 2, 4c2, 1 by 2 power of x, x is none other than again 2, into q is 1 by 2, n is 4, x is 2, 4 minus 2, plus 4c, x is 3, into p is 1 by 2, x is 3, into q is again 1 by 2, n is 4, minus x is 3, plus x is 4 here, so 4c4, 1 by 2 power of x, x is none other than 4, into q is 1 by 2, n is 4, minus x is 4. Now let me simplify. So 4c1 unit, 4c1 is 4. 4 into 1 by 2 power of 1 is 1 by 2 only, 4 minus 1 is 3, 1 cube is 1, 2 cube is 8, so 1 by 8, plus 4c2, 4c2 is 6, into 1 by 2 square is 4, again 4 minus 2 is 2, 1 square is 1, 2 square is 4, fine, plus 4c3 is 4, into 1 cube is 1, 2 cube is 8, 4 minus 3 is 1, so you will get 1 by 2 as it is, plus 4c4 is 1, into 1 by 2 power of 4, so 2 power of 4 is 16, 1 by 16, 4 power of 4, 4 minus 4 is 0, 0, anything power 0 is 1, so you will get numerator is 4, 8 2s are 16, plus 6 divided by 16, plus 4 divided by 16, plus 1 divided by 16, so when you take LCM, you will get 4 plus 6 plus 4 plus 1, 6 plus 4 10, 10 plus 4 14, plus 1 is 15 by 16, so this is the probability of getting at least one boy. Fine. Probability of getting at least one boy is 15 by 16. Now we need to calculate at least one boy and at least one girl. Coming to the second sub question. Hope so first question is clear for you. Let me solve the second sub question. It is probability of getting at least one boy and at least one girl. So to calculate this, first we have to calculate at least one boy, in the sense probability of getting at least one boy, two boy, three boy and four boy. again, and in the sense we have to add it for at least 1 girl, 2 girl, 3 girl, 4 girl. So it takes lot of procedure and lot of time and lot of space to do all these things. So we can solve this problem by using the concept of complementary event. So probability of any event and its complement is given by 1. Sum of its complement is given by 1. Or else we can write probability of A is equal to, probability of A plus probability of A bar is equal to 1. So we can write by using the complementary event. So you just remember this concept, 1 minus probability of no by. This also you should get complement here, minus probability of no girl. This is shortcut method, otherwise you don't have any way. You have to remember this concept, otherwise you have to find at least 1 by, 2 by, 3 by, 4 by. And then you have to find at least 1 girl, 2 girl, 3 girl, 4 girl, and then you have to add both in order to get the solution for this. Instead, we are using this formula. You need to remember this formula. Here, no by in the sense we have to take x value 0. No girl in the sense again it is 0. So let me simplify 1 as it is. No by x is equal to 0. Let me substitute in a formula. N value will not change. 4c 0. P value is 1 by 2. X value is 0. Q value is 1 by 2, N value is 4, minus X value is 0. Fine. Minus probability is again using the formula, N value is 4, C, X value is 0, P value is 1 by 2, X value is 0, again Q value is 1 by 2, N value is 4, minus X value is 0. Clear? Now let me simplify. 1 minus 4C0, 4C 0 is 1. 1 into any value power 0 is 1. Now 4 minus 0 is 4. So you will get 1 divided by 2 power of 4. So you will get 2 power 4 is 16, right? So I'll just write the same. Minus 4C0 is again 1. Again 0. You will get 1 by 2 power of 4 minus 0 is 1 divided by 16. I'm sorry, it is 1. Why? Because 1 by 2 power of 0 is 1. So what you're going to get is 1 minus 1 by 16 minus 1 by 16. Right? Now, let me simplify this by taking the LCM. 16 will be the LCM. So you will get 16 here. 16 minus 1 minus 1. So you will get 16 minus 1 is 15 minus 1 is 14. So 14 divided by 16. Therefore, probability of getting at least one boy and at least one girl will be equal to 14 by 16. Clear? So here is the next question. If 20% of the boards produced by a machine are defective, determine the probability that out of 4 bolts chosen at random, 1 bolt is defective, 0 bolt is defective, less than 2 bolt is defective. Here, main theme, that is a probability of success event, is none other than a defective bolt. Right? Why? Because we need to find the bolt which is defective. So we have to choose that as a success event. Right? So let me take, I'll just write the solution here. Let me take probability P as probability of a defective bolt. Fine. So what it is given, 20% of the boards produced by the machine are defective. So it is given in the problem itself. It is 20%. Remember, when you are talking about percent, you have to divide the number with 100. Right? So I can write 20% as 20 by 100. So that will give you 0.2. Now go to the problem. What else is given? The probability that out of 4 bolts chosen at random. So how many bolts are chosen? 4 bolts. So n will be equal to 4. So as you already know the value of p, we can calculate the value of q by using the formula q is equal to 1 minus p. So q is equal to 1 minus p is 0.2. So q will be equal to 0.8. So once you have obtained the value of q and the value of p and the n value is known, let me calculate the sub questions now. What is the first sub question that we need to calculate is probability of out of 4 bolts chosen at random, 1 bolt is defective. That is, we need to find probability of 1 bolt is defective. First one, probability of 1 bolt defective. So clearly here the value of x is 1. Right? What is the formula? First you need to write formula whatever may be the problem. What is the formula? NCX p power of x q power of n minus x. Here the value of n is 4. So 4c1 into p value is 0.2 whole power of x. X is 1. Q value is 0.8 whole power of n is 4 minus x is 1. Now what you have, 4c1 into 0.2 into 0.8 power of 3. I'll just simplify in one shot. See here, 4c1 into 0.2 into 0.8 whole cube. So that will give you 0.4096. Fine. So this will be the probability of 1 bolt which is defective. 1 bolt which is defective. Remember, whatever may be the probability, the value should be in between 0 and 1. So this is the solution for first sub question. Now look at the second sub question. What we have is 0 bolt defective. So the bolt which is defective is 0. In the sense, second one, probability of 0 bolt defective. So here the value of x is 0. So substitute in the formula. So you will get 4c0 into p power of 0. P is 0.2. I'll just substitute directly. 0.2 power of 0 into what is the value of where is the formula? Here is the formula. So p value have done. Q value is 0.8. Power of n is 4 minus x is 0. So you will get 4c0. Anything value power 0 is 1 into 0.8 power of 4. So you will get 4c0 into 0.8 power 4. So you will get 0.4096. So this will be the probability of bolt which is 0 defective. Fine. So this is the solution for second sub question. Fine. Now let us look at the third one. Probability of bolt which is less than 2 bolts are defective. Fine. So as I already told you, when it is less than 2 bolts, in the sense it is 0 and 1. Less than 2 is none other than 0 and 1, right? So I'll just write here probability of less than 2 bolts defective. What it is? It is probability of 0 bolt defective plus probability of 1 bolt defective. Right. Moreover, no need to calculate 0 bolt defective. Why? Because we have already done it is 0. I'll just substitute here 0.4096 plus what is the probability of 1 bolt defective? It is 0.4096. So when you add both, you will get 0.8192. So this is the probability of bolt which is less than 2 bolts defective. Probability of less than 2 bolt defective. Just complete the statement. So this is given by 0.8192. It is 0.8192. So this is the required solution for the third one. Hope so it is clear. Right. So all the 3 sub questions are solved. That's it. Now let me solve one more problem. So here is the next question. It is important question, and this will be the last problem in binomial distribution. Anyhow, in the next session I will be continue with the normal distribution. So out of the 2000 families with 4 children, each in 2000 family there are 4 children each. So how many would you expect to have? At least 1 boy, 2 boys, 1 or 2 girls, no girls. Assume that the probability of boy is 1 by 2. Remember, in such kind of problem, since probability of boy is given, so that will be the success event. So we have to take that as P. Fine. So P is probability of, why? Because it is noun terms and moreover it is a reference for us. Anyhow, we need to find boys in first and second question. In third and fourth it is girls. So as it is given in the problem, we have to take that as a P. That is success event. Probability of boy which is equal to 1 by 2. Fine. So Q can be calculated by using the formula. It is 1 minus P. So 1 minus 1 by 2 is again 1 by 2. Clear? Now look at the question given here. Well, first question is what we need to find. At least 1 boy. At least 1 boy. So as I already said, when we calculate at least 1 boy, at least in the sense you have to go more. So how many children are there? Totally 4. So you have to take n as 4. So at least 1 boy, in the sense it will be equal to probability of 1 boy plus probability of 2 boys. Why? Because we cannot go 0. Why? Because we are starting from 1. At least 1 in the sense after 1 you have to go. So probability of 2 boys plus probability of 3 boys plus probability of 4 boys. Clear? Now probability of 1 boy, second boy, third boy and fourth boy we need to calculate. So when I said probability of 1 boy, it will be x will be equal to 1. So here x is equal to 2, here x is equal to 3, here x is equal to 4. So what is the formula to calculate it? Binomial distribution is NCX p power of x q power of n minus x. Now let me substitute. I'll just make use formula directly. So here n value is 4. 4c1 p is 1 by 2, x power is 1 only. Fine. So I'll put x1 here. Q is again 1 by 2, n value is 4 minus x value is 1 plus again here 4c x value is 2. This is the formula I am substituting in it. 4c2 p is 1 by 2, x value is 2, q is 1 by 2, n is 4 minus 2 plus 4c x value is 3, 1 by 2 cube 1 by 2 power 4 minus 3 plus 4c4, why? Because x value is 4, p is 1 by 2 power 4 into q is 1 by 2 power 4 minus 4. Clear? As usual substitution. Now let me simplify. I'll just use the calculator. 4c1 is 4. So 4 into 1 by 2 into, what is the value of 4 minus 1? 3. So you will get 1 divided by 2 cube is 8 plus 4c2. 4c2 is 6. 6 into 1 by 2 square is 4 into 4 minus 2 is 2, 1 by 4 plus 4c3 4 into 1 by 2 cube is 1 by 8 plus 4 minus 3 is 1, 1 by 2 you will get as it is. Next 4c4 is 1, again 1 by what is the value of 1 by 2 power of 4? It is 1 divided by 16 into 4 minus 4 is 1, so you will get 1 only. Clear? Now let me simplify. 4 divided by 8 2 is a 16 plus 6 divided by 16 plus 4 divided by 16 plus 1 divided by 16. Let me take LCM. It is 16, so you will get 4 plus 6 plus 4 plus 1. 6 plus 4 is 10, 10 plus 4 is 14, plus 1 is 15. So it is 15 by 16. Therefore, probability of getting at least one boy is 15 by 16. Clear? Now, second question. What is the probability of getting 2 boys? Probability of getting 2 boys. See here, probability of getting 2 boys we have already calculated here. Anyhow, if you want, you can let me calculate. 2 boys in the sense x is equal to 2. So NC2, 4C2, p power of x, 1 by 2 power of 2 into q is 1 by 2, n is 4 minus x is 2. So 4c2 value is, we have already done. 4c2 is 6 into 1 by 2 square is 1 by 4 into 1 by 2 power of 4 minus 2 is again 1 by 4 it is. So after simplification you will get 6 by 16. I'm sorry, it is 6 by 16. If you want, you can simplify further. Fine. So it is 6 by 16. And one more thing is that you have to, this is very important. Why? Because it is quite different. See here, out of 2000 families with 4 children each, how many would you expect to have? How many would you expect to have out of 2000 families? So there are totally 2000 family. In 2000 family we have to calculate at least one boy. See, this is a probability of getting at least one boy for one family. Since we are calculating with reference to 2000 families, so we need to multiply this. So here there is a continuation. Therefore you just write it, expected number of families with at least one boy will be equal to, you have to multiply, right? So 2000 into 15 by 16. So 16 ones are 16 125. So after multiplication you will get 1875. So this is the required solution for the first sub question. Remember why? Because we have calculated probability with reference to, at least 1 by with reference to only one family. But it is given that out of 2000 families, so we are multiplying for 1. For 2 you are going to multiply 2. For 3 family you are going to multiply 3. For 2000 family we are going to multiply it with 2000. Similarly here also probability of getting 2 by 6 by 16. Therefore we have to calculate expected number of families with at least 2 by's. I'll just write here. Therefore, expected number of families with 2 boys will be equal to, you have to multiply 2000 for the obtained probability. It is 6 by 16. Clear? 16 ones are 16, 125 are. Oh yeah, 16 125 it is correct. So 25 into 6, 125 into 6 you have to calculate, so it is 750. So this is the required solution for the second one. I'll just repeat once again. After finding the probability you have to multiply with 2000. Why? Because expected number of families we need to calculate, since it is given in the problem that expected number is 2000 family, so we have to multiply it with 2000. For the second one also I have done the same. 2000 multiplied with 6 by 16, that is what the obtained probability is. Fine. Now look at the third question. What is the third question? We have 1 or 2 girls. 1 or 2 girls. So third question I will be doing here. Third one. Probability of 1 or 2 girl. 1 or 2 girl in the sense, are in the sense and in the sense, are in the sense addition, and in the sense multiplication. I have already told you R is nothing but addition, and is nothing but multiplication. Since you have R here, it is none other than probability of 1 girl plus probability of 2 girl. 1 girl in the sense x is equal to 1, 2 girl in the sense x is equal to 2. So let me simplify by using the formula. N is in the given problem. See here, n is equal to 4. Substitute in the formula. 4c1 1 by 2 power of 1 into q is 1 by 2 power of n is 4 minus 1 plus 4c. See, the procedure is very easy, but it is lengthy. You have to manage the time. So it will be happen only when you practice well. Fine. 4c, x value is 2, p is 1 by 2, again x value is 2, q is 1 by 2, so n is 4 minus 2. So 4c1 value, 4c1 is 4 into 1 by 2, 4 minus 1 is 3, 1 by 2 power of 3 is 8, plus 4c2, 4c2 is 6 into 1 by 2 square is 4 into 1 by 2 square is again it is 4. So you will get 4 by 16 plus 6 by 16. Right? So let me take 16 as an LCM. So you will get 10 here. So 10 by 16. But we need to calculate expected, right? Therefore, expected number of families with 1 or 2 girls. So you have to multiply it with 2000. Why? Because in the question it is given that there are 2000 families. Now let me multiply. So after simplification you will get 16 ones are 16 125 are. So you will get 1250. So this is the required solution for third sub question. Clear? So this is for second sub question. Fine. This is for first sub question. Now look at the fourth question. What is the fourth question? We have no girl, that is 0 girl, right? I'll just do fourth question here. Fourth question is probability of no girl. No girl meaning is x is equal to 0. Substitute x is equal to 0 in formula. You will get 4c0 into 1 by 2 power of 0 into 1 by 2 power of 4 minus 0. So 4c0 is 1 into 1 by 2 power of 0 is 1 into 1 by 2 power of 4 is 1 by 16. So you will get 1 by 16 here. Now we have to write expected number. So you have to multiply. Therefore expected number of families with no girl is 2000 into 1 by 16. 16 ones are 16, 125 is. So you will get it as 125. So this is the required solution for the fourth sub question. Hope so it is clear, right? See here I have done, only difference in this problem is total we have to calculate. In the sense, for total 2000 family we have to calculate. What are the probability we have obtained? It is for only one family. So for total you have to multiply it with 2000 family. So multiplication give you this solution. So this is the second sub question, where for 2 boys probability is 6 by 16. This is for one family. So for 2000 family you have to multiply. Similarly for probability of 1 or 2 girls, so this will be the required probability. But after multiplication it for 2000 family, so you will get this solution. For fourth sub question this will be the case. So hope so whatever I have done so far, it is clear for you. So this completes the problems on binomial distribution. In the next session I will be continue with the normal distribution.